Alright, so let's handle the next proof. The next proof required you to do this. It requires you to prove that the absolute value of x plus y is less than the absolute value of is less than or equal to the absolute value of x plus the absolute value of y. Okay. So like I already said, you need to test all the possible cases because you are trying to prove that something is true. Okay. There is like no way we know that this is false. So we have to test all the possible cases. So we say x is 0, y is 0, right? That's one case. Now, there's also another case where both x and y are greater than 0. There's also a third case where x is less than 0 and y is greater than 0. Then there is one more case where x is less than 0, y is also less than 0. That's both are negative, right? So you take your time. If x is equal to 0 and y is equal to 0, in the end, you just be doing the absolute value of 0 plus 0, which is equal to 0. Now you realize that if you take x plus y without the absolute value and you would compute the absolute value of x plus y, right, you get 0. So it means that this case, the first part, which says that it is either equal to what? It is less than or equal to the magnitude of x plus the magnitude of y is satisfied, right? Now you can So this is just the remaining lines are just explicit definitions, right, of the previous one. So if you take the absolute value of x plus y, when both x and y are 0, then it is equivalent to the absolute value of x plus the absolute value of y. Now we come to the second part. Let's assume x is greater than 0 and y is greater than 0. Then we know that obviously when we add x and y, we get a value greater than 0. Now, what does the absolute value do? The absolute value will always produce a positive, right? So if x plus y is greater than 0, then the absolute value of it will also be what? Will be greater than 0, right? So we also look at the flip side where we consider it individually. Fine, we've done both of them, right? Magnitude of x plus y. Now let's do it individually. So individually, if you do magnitude of x plus magnitude of y. Now since magnitude of x was positive, magnitude of y is also positive, then you realize that at the end of the day, this one will be equal to this one, right? So you can just choose any number. If you choose 3 and 2, positive 3 and positive 2, when you add them, you get 5. When you find the magnitude, it's still 5. And when you find the magnitude of 3, it's what? 3. Plus the magnitude of 2 is also 2. When you add it, you still get 5. So it's the same thing. Then you can go ahead with the next one. The next one says if x is negative, that is if x is less than 0, and y is positive. Now, here you have to consider flip sides. Assuming that this statement is holding, right? Now, this statement can hold for when the absolute value of x is greater than the absolute value of y. Remember, we said that the absolute value of a number will change a negative number to a positive number, right? So it means that if I'm considering two numbers and one is negative and the other is positive, right? It means that there is the possibility that if I take the magnitude of the numbers, right, the one which was negative initially will become greater than the one which was positive. So for example, if I had used negative 10 and maybe 7, if I find the absolute value of negative 10, I'll get positive 10. Absolute value of 7, I'll get positive 7, right? Now, initially, negative 10 was less than 7. But after I find the absolute value, I'll get what? I'll get positive 10 is greater than 7. Do you see it? So that's the case they are trying to evaluate here. So if that is the case, then realize that if I do pure x plus y without the absolute value, if I do minus 10 plus 7 without the absolute value, I get minus 3. So I get another value which is less than 0, right? Now, that implies that me doing x plus y is the same as the absolute value of x plus y is the same as me doing the negative of x plus y. This is what they are saying. It's saying that I was coming to do this one, absolute value of x plus y, right? And now we know that x is minus 10 and y is what? 7. Now, it says instead of me doing this, I could also have done, I'll put a negative in front of it. and I'll do what? Minus 10 plus 7. So minus 10 plus 7. Now, this will give me what? Minus 3 here, right? And this will give me 3 at the end. This will give me what? Minus 10 plus 7 will give me what? Absolute value of minus 3, which is equal to what? Positive 3. So you realize that this answer and that answer are equal, right? So that's what he's saying here, right? Now you realize that when you expand this bracket, you come and get this. You get minus x plus minus y. Now, in the case where x was negative and you found the absolute value, right? But y was positive and you find the absolute value, you realize that you summing them individually will actually give you what? The negative value of x plus the y, which was already positive. Now see something. What you realize is that if I take minus 10 and positive 7, right? If I find the absolute value of minus 10 alone, I get what? Positive 10. Now if I add it to 7, I get what? 17. Now 17 is greater than what? The 3 we evaluated for, right? So you realize that then the resultant equation, magnitude of x plus y, will be less than the individual. So this is the individual, right? And we did the individual, we got 17. But when we did it separately, when we did the individual, we got 17. But when we did it together, we got 3. And that's what you see. Now, it follows from the same from the others. So it's the same logical reason. And the proof is not hard. So at the end of the day, when you go through it step by step, right, you can be able to do it. Now, let's take one more example. Okay, now this is not a proof, but this is also another region of the inequalities, right? Now, your whole life, when you are solving quadratic equations, you have been told, oh, factorize them. So when you had maybe x squared minus 2x plus 1, right? You usually come out with x minus, that the solution of x minus 1 squared is equal to 0, right? So you can see what x is equal to what? 1, right? Now, anytime you had x plus 3 times x plus 2 is equal to 0, you can equate them individually and you can say x plus 3 is equal to 0. So x will be equal to minus 3. Or x plus 2 is equal to 0. So you can say what x is equal to minus 2. So these will be the two answers of your equation. But for inequalities, it's different. For inequalities, you have to be very particular about the signs, right? So let's take an example. You have an example of x squared minus 3x minus 2 is less than 10 minus 2x, right? Now, you group like terms just like we were doing for the equation. So when you group like terms, you come and arrive at this. I hope by now grouping like terms shouldn't be difficult. So when you start grouping like terms, you realize that you come and get x squared, then minus 3. This one comes, it becomes plus 2, so comes out minus 6. Then minus 2 minus 10 is minus 12. It's less than 0. Now when you factorize, you're able to get this x minus 4 multiplying x plus 3 is less than 0. Now, don't go and say x is less than 4 or x is less than minus 3. This is wrong. Don't do this. This is wrong, right? This is an inequality, not an equation. So you can't equate them individually. So the first thing you do is that usually they have a geometric solution, right? And the geometric solution is simple. It says take the number line, right? Now when you take the number line, you realize that you realize two things, and those two things are, you see, either from x minus 4 greater than 0 or x plus 3 greater than 0, right? Now when you try to represent them geometrically, when would a number subtracted from 4 be greater than 0? It means that the number should be 4 or greater. Do you understand? Yes. Realize that any value of x you put here, which is less than 4, will make this statement false, right? So it means that the number should be 4 or greater. So it means that we have to start at 4, right? And so you draw a line indicating that you are starting at 4. Now, x plus 3 is also greater than 0. Now, when is a number added to 3 greater than 0? It means that the number has to be what? Minus 3, the number has to be greater than minus 3, right? So you realize that we start from here, right? So we start from minus 3 and we draw the RODC. Now, you realize something, right? And what you realize is that the upper bound of the solution, right, is at positive 4, right? That is, the greater the solution can go is positive 4. And the lower bound of the solution is at what? Minus 3. Now, this is just graphical. So you can see that fine. Then minus 3 should be less than x, and x should be less than 4, right? Now, probably might have confused you. Why should I have said, let's set x minus 4 greater than 0, and let's set x plus 3 also greater than 0 here? Well, when you realize that anytime both of them are greater than 0, then you are more or less finding the minimum range at which this statement will be false, so that you can see the ranges with which they will be true, right? Now, there is also another way, right, which is purely analytical. So if you don't get the first one, you can use this one. So in this way, you try to consider all the possible ways, right? Now you have two exponentials multiplying, x minus 4 and x plus 3, less than 0. So you can see fine. Two numbers multiplying will only give you 0 if one of them is negative, right? So you can say, okay, then let x minus 4 be greater than 0, and let x plus 3 be less than 0. So which means that you are assuming you are choosing a value for x, which makes this one positive, and you are choosing a value for x, which makes this one negative, right? Now, you realize that you come and get an x which is greater than 4, but that same x is also less than what? Minus 3. Now, this is impossible, right? Now, the second option is that you can reverse the process. You are choosing a value such that x minus 4 is less than 0 and x plus 3 is greater than 0. And you realize that you can get an x which is less than 4, right? And that same x is greater than minus 3, right? And that is visible. I mean, there are values which are less than 4, but they are greater than minus 3. 0 is an example. So you realize that this one is more feasible than the previous one. So this is purely analytical, right? And given below are some exercises you can try yourself. Probably put the solution to the video link as well. But yeah, for the sake of clarity, that's what you observe. You observe that in inequalities, you don't just equate your individual solutions to 0 and find the value of x's, right? So you don't just say x minus 4 is less than 0, because if here had been an equal to sign, right? Someone would have said, oh, x minus 4 is equal to 0. Let me clean this part so that I show it clearly. Someone would have said x minus 4 is equal to 0, or x plus 3 is equal to what? 0. Now, if this was an equal to sign, yeah, these two are correct, right? But if it's an inequality, no, you can't do that. You have to analyze the solution. You have to analyze the situation at hand before you make your analysis, right? Probably I'll be adding more examples on these. The examples are depleted in this slide. So yeah, that's all for this video. Thank you.